I've got some bins, as you can see here, labelled A up to F, and each of those bins has a capacity of 6. Now I've got some rectangular objects that I'm going to insert into the bins, and what I want to do, ideally, is pack as efficiently as possible, so avoid wasted space. I'm going to take each of my objects in turn and place them in the first bin that has space for it.
The teacher here is introducing students to some widely used bin packing algorithms. This is prior to using a practical activity which is designed to deepen their understanding of these algorithms and help consider how different situations may affect the choice of which algorithm to apply. A colleague has agreed to observe and listen to their reasoning.
So we've ended up with 6 bins used. But as you can see, we have got wasted space. I wonder if there's a better way of proceeding through that algorithm. I'd like you to have a think about that. In fact, talk about it with the person next to you. So what I tend to find with some of the algorithms that students need to learn, the sorts of problems that they're presented with in textbooks, exam papers, often involve a very small amount of information because it's not practical in those situations to give them the sorts of size of data that a program would be written for. So sometimes there's an issue with students perhaps not understanding and appreciating the need for an algorithm, and also perhaps not appreciating the key features that an algorithm has to have. Ollie, I think I heard you two talking about choosing a different one first.
I would go for put the 6 in first, and then I think about different numbers that add up to 6. So 5 and 1 add up to 6, and I'll put them together. 4 and 2, and 3 and 3.
Let's take the idea of starting with the big one first. Putting everything in order, starting with the biggest one, going through to the smallest one. And let's work through that same process again and see what happens this time. Try each one in the first bin that it will fit. So there we go. By doing it that way, by starting with the larger items and then working through systematically, we've got to a situation where we've only used 5 bins rather than the 6. Do you think it's always best to start with the big one?
Starting with the biggest is more logical. You shouldn't have the big ones left over at the end because then there's just no way that you can actually fit them in.
Okay, I'm going to give you some bins to pack. You're going to get a pack of rods. There were 2 different ways of approaching the same problem. Some of them had been given the rods in a clear bag so they could see all the different rods that they had to sort and use that decreasing fit approach. And other students, the rods were in envelopes so they couldn't see, so they were taking that one at a time. That was designed in such a way as to really bring home the fact that whilst it might be that decreasing first fit looks like it's the best approach, sometimes you can't have that, sometimes you have to do it the other way. And they also had a chance to then play with it and get an optimal solution through trial and error. The task was set up in such a way as to enable them to compare 3 different methods and get quite in-depth discussion about which was preferable and consider situations where one might be better than another. Was that your final solution?
No, that's using that method.
Using the decreasing first fit. So maybe try a different approach to see what happens. Do you think you've got the perfect solution, the optimal solution?
It's pretty efficient, but it's not.
Okay. So perhaps we could try the other approach, see if that's better?
Yeah. 6. That's 6, that's 4, so it'd leave 2. Or you go 3 and 3, then you've got 6 and 6.
Yeah, there you go. So how did you arrive at that? Was that a strategic approach or trial and error? So if I were to give you a problem like this to do, what do you think you would do? Would you go for one of the methods we looked at on the board at the beginning, or would you go straight for trial and error?
I think I'd start with that, and then if that doesn't give you the right result,
So it's quite quick to
I'd
do
go
that,
to
yeah.
The good thing about this was, after we did it, we realised that 2 could fit in there, which made us be able to do that.
Okay.
We sort of looked at that and realised that we could.
Right. So rather than starting completely from scratch, you had a situation where you got maybe not the optimal one, but it gave you a starting point that you can then tweak rather than just going straight for completely starting from scratch. Initially, at the front, you were taking one piece at a time without knowing what the rest of the contents of the bags were. So you were using effectively the first version of the algorithm we saw. And the table at the back, because your bag was clear, you could see all the rods at the beginning, so you had a bit more freedom to decide. And you did have a go to begin with, didn't you, using the sourcing idea of putting them in from biggest to smallest first. Did that give you the best solution? No, not quite. And then people at the front, did either of you get the perfect solution first way around? No. This method that we've looked at can be more efficient, but it doesn't necessarily guarantee the best solution. When they were introduced to the algorithm at the start of the lesson, they all understood intuitively the idea of putting the big ones first if you had control of seeing them all, but actually by forcing them to take them out one at a time made them consider situations where perhaps that isn't possible.
Those students who did order the pieces first still didn't get an optimal solution. They were disappointed with the solution they got, and were determined to tweak it.
This task helped them, I think, to appreciate that the physicality of having the bits to try to fit in does help to get the message across that we can aim for that perfect solution, but it won't always be there, and neither does the algorithm always get it. Flexibility of approach might be needed.
Yeah.